Hi everyone. Let's start again. Paper 4 of A-level structured questions, October-November 2025, variance 44. We have done variance 41 and 42 in the previous classes. Let's talk about variance 44. Question 1. Define transition element. An element which can form one or more stable ion having partially filled d orbital. Is called transition element. Okay. The 3D orbitals in an isolated gaseous copper-2 ions are degenerate. Define the term degenerate. Degenerate means equal energy orbitals. Okay. Now the next is complete electronic configuration of copper-2 ions. By the way, copper atom has an atomic number of 29. So its general sort of configuration is argon, 3d10, Nn4s1. So for copper-2 ions, two electrons are lost. One is lost from the 4s orbital and another one is lost from the 3d orbital. So configuration is going to be like this: 1s2, 2s2, 2p6, 3s2, and then 3p6. So these are the 18 electrons, and these 18 electrons shows argon. Okay. Now we have 3d9 and 4s0. All right. So that's the electronic configuration of copper-2 ions. State the color of the aqueous solution for the two copper-2 complex ions shown. This complex ion has dark blue color or deep blue color, and this has yellow color. All right, and that's what we have done in the class, right? Next is explain why aqueous complex ions of transition elements are usually colored. First point is degenerate d orbitals splits between two energy groups due to absorption of energy or due to dd electronic transition. Electron is promoted from low energy d orbital to high energy d orbital. So during this electron promotion, certain wavelengths are not absorbed. That corresponds to the color of the solution observed. That corresponds to the color of solution observed. And this sentence shows that a complementary color is observed. By the way, these two energy groups, one is T2G and the other one is EG. T2G has 3 groups of d orbital and EG has 2 groups of d orbitals. All right. Anyway, let's move on to the next part. When excess aqueous ammonia is added to this solution, okay. So we have CuCl4 2 minus. When we added 4 ammonia molecule, then there will be a ligand substitution reaction. And because of that, we'll get this complex. Okay. So type of reaction is basically ligand exchange or ligand substitution reaction. Why does ligand substitution reaction or ligand exchange reaction? Because ammonia is a stronger ligand and water is also a stronger ligand. So both of them can displace chloride very easily. Okay. Since I'm using 2 water molecules, so in order to balance the equation, let me put 2 water molecule also. Okay. Oh, examiner is looking for the equation. So let me write 4NH3 plus 2H2O plus 4 chloride ions. So that's the equation. And that's easier. That's not that much difficult, okay? So both ammonia and water are stronger ligand. They can displace chloride ion easily, which is why it is ligand substitution reaction or ligand exchange reaction. Let's move on to the next page. This complex ions shows stereoisomerism. And obviously this complex has a situation of Ml4 and X2, which means this situation shows geometrical isomerism as we have monotented ligands in the complex ion. So examiner is looking for the 3D diagram in which we need to show the 2 different stereoisomers of this complex ion. So in 3-dimensional diagram, we must have dotted line and pyramid. Okay. So let's suppose these 2 water molecules present on the same side, so it's going to be cis. And these 2 water molecules are diagonally attached together, so it's going to be trans. And we need to put ammonia molecule like this. Bonding नाइट्रोजन से शो करेंगे हमेशा, ऑक्सीजन से शो करेंगे, because nitrogen and oxygen both of them have lone pair. Okay. So this is going to be cis, this is going to be trans. Describe which isomer, I mean stereoisomer in D part 2 is polar. Cis is polar because in cis isomer, there will be no cancellation of dipole moment. Or we can write, because in cis isomer, there will be a net dipole exist. The dianion means anion carries 2 plus 2 minus charge. Acts as a tridentate ligand. In class we had monodentate ligand, bidentate ligand, polydentate ligand, but this time examiner is using tridentate ligand. Tridentate means donate 3 lone pairs to the transition element. Okay, so this one is the first lone pair. All right, this one is the second lone pair, and this one is the third lone pair, which is why it is a tridentate ligand. Suggest how P can form 3 dative covalent bonds or dative bonds or coordinate covalent bonds. Because P has 3 lone pairs, so it donate 3 lone pairs to the transition metal line. So 3 dative bonds are formed. Two moles of dianion P. See, it is a tridentate ligand, and we are using 2 moles, which means it can form 6 dative bonds, right? So technically, coordination number is going to be 6. With 1 mole of aqueous cobalt 3 ions to form 1 mole of complex ion Q. Okay, deduce the formula in charge of Q. All right. Okay. So we have cobalt 3 ions. We have this complex C4, H5, NO4. Since we are using 2 mole, so it must be taken 2. And now we need to find the charge on this complex sign. चार्ज कुछ ऐसा होना चाहिए कि कोबाल्ट की ऑक्सीडेशन स्टेट +3 हो, और याद रहे कि this complex has -2 charge, right? So cobalt, let's suppose, is X. This ligand has -2 charge, We have two ligands, so it's going to be into 2 equals to charge. Then X equals to charge plus 4. And to get the plus 3 charge, obviously to get the plus 3 oxidation state, the charge has to be minus 1. Okay, I hope it makes sense to you. Let's move on to the next page. Table 1.1 shows the value of the stability constant for some Silbermann complexes. We have done these 3 complexes in the class. These 2 we have done in A2, and this one we have done in AS. All right. Define stability constant of a complex. That's an easy thing. Stability constant. It is a ratio of the concentration of product to the concentration of reactant from its constituent ions using a solvent. Okay. So stability constant is basically the ratio of the concentration of product to the concentration of reactant. Oh, that's concentration of reactant is missing. To the concentration of reactant from its constituent ions or molecules under equilibrium using a solvent. Okay. Because usually the molecules and ions always exist in aqueous state. In aqueous state means there must be a water, and that is going to be a solvent. Okay. Next is use the information in table 1.1 to identify the most stable Silbermann complex. Explain your answer. The most stable having a more higher value of stability constant. So AgCN taken 2. And this is negative sign. Explanation: because its stability constant value is highest. Okay. My goodness, that's a huge question. Sodium sulfite is used as a food preservative. 3.75 gram impure sodium sulfite is dissolved in distilled water and made up to 250. 10 cm cube of this solution requires this much amount of manganate ions for the endpoint. Equation is given. Calculate the percentage by mass of sodium sulfite. So first of all, take out the moles of manganate ions. We have 18.70 into 0.0150 and divided by 1000. So the moles of manganate ions is going to be 2.805 into 10 to the power minus 4 moles. Now, according to the equation, manganate ions and sulfite ions has 2:5 ka ratio. When we have 2.805 into 10 to the power minus 4, so the moles of sulfite ions is going to be, so moles of sulfite ions is going to be 7.0125 into 10 to the power minus 4 moles. And obviously, these moles we have got in 10 cm cube. So in 10 cm cube, we have 7.0125 moles into 10 to the power minus 4 moles. So in 250 cm cube, the moles would be how much? 7.0125 into 10 to the power minus 3? Minus 2, I think so. 7.0125 exponent minus 4 into 250 divided by 10. So it's going to be 0.01753. So it's basically minus 2. Okay. Take out the MR of sodium sulfite. So it's basically 23 times 2 plus 32.1 plus 16 times 3. So the MR of sodium sulfite is going to be 126.1. We know the moles of sodium sulfite, which is 1.7. Oh, no, hold on. It's basically 7.0125 into 10 to the power minus 2 into 126.1 into 126.1. So its mass is basically 2.2106. 2.2106 gram. We need to get the percentage. So for that, 2.2106 divided by the mass of sample, which was 3.75 into 100. So this is going to be the mass of pure, this is mass of impure into 100. I'll get the concentration divided by 3.75 into 100. It's going to be 58.95. Okay, so the percentage is basically 59.0%. Because minimum two significant figures to mention करने होते हैं आपको, okay? So that this question has 19 marks. That's why it was a huge question. Okay. Let's move on to the next question, guys. I hope it makes sense to you. I hope I didn't miss any part of this question. Yes. Next question is my favorite. Group 2 sulfates and group 2 chromates show similar trends in solubility. So down the group, solubility of group 2 sulfates and chromates decreases. Suggest the trend of the solubility of the group 2 chromates down the group. Explain your answer. Down the group, ionic radius increases. As a result, charge density decreases. C, Group 2 sulfates and carbonates can be explained on the basis of lattice energy and hydration enthalpy. And both lattice and hydration depends on charge density, and both lattice and hydration are exothermic in nature. So when charge density decreases, both lattice energy and hydration enthalpy decreases. And if both lattice and hydration enthalpy decreases, so down the group, hydration enthalpy decreases more significantly than lattice. So standard enthalpy change of solution becomes endothermic. And therefore solubility of group 2 chromates decreases. Okay. Now silver 1 chromate is sparingly soluble in water. Write an ionic equation to show the equilibrium between solid silver chromate, which has a formula of Ag2CrO4. It ionizes slowly and reversibly into silver ions and chromate ions. By the way, CrO4 has 2 minus charge. Since we have 2 silver atom here, so I need to put 2 here. This is solid, and these 2 are aqueous as they are ions. Okay. The value of solubility product of silver chromate is given. Calculate the equilibrium concentration of silver ion in mole per dm cube in a saturated solution. Okay. So KSP. Oh, hold on. Let me write this equation again. Okay. According to the equation, both of them has 1:1 ratio, and with silver ion it has 2. We need to find out the concentration of silver ions. Since it has 2 moles, so let's suppose it's going to be 2x, and since it has 2:1 ratio, which means if it is 2x, it must be an x. Let me write it down, the KSP expression for this. Concentration of silver ions, power square, because number of moles has to be in power, and concentration of chromate ions. So KSP की value is given 1.12 into 10 to the power minus 12 equals to, silver ion is 2x and then square, and this value must be x. So 1.12 into 10 to the power minus 12 equals to 4x cube. So to get the value of x, we need to take out the cube root of this value. So it's going to be 1.12 into 10 to the power minus 12 divided by 4. So the value of x is going to be 6.54 into 10 to the power minus 5 mole per dm cube. We need to find the concentration of silver ions and we know the concentration of silver ions was 2x. 2 will remain as it is, and the value of x is 6.54 into 10 to the power minus 5. So it must be how much? 1.31 into 10 to the power minus 4 mole per dm cube. So that's the answer. 1.31 into 10 to the power minus 4 mole per dm cube. I hope it makes sense to you. By the way, this sort of question we have done in the class. मैंने ये डिस्कस किया है फॉर्मेट आपके साथ जिसमें हम क्यूब रूट निकालते हैं. आई थिंक मैंने डिस्कस किया है मैग्नीशियम हाइड्रोक्साइड में, बट सेम चीज है, सेम क्राइटेरिया अडॉप्ट किया हुआ है मैंने. नेक्स्ट पेज. The hydrogen chromate ion is a weak acid and the pK of this acid is given. Calculate the concentration of pH. Calculate the pH of this concentration of chromate ions. So first of all, take out the value of Ka by using this expression. pK value is given, which is 6.49 equals to minus log Ka. So the value of Ka from here is shift log minus 6.49, shift log minus 6.49. So it's going to be 3.235, 3.236 into 10 to the power minus 7 mole per dm cube. In the next step, if you remember, we have discussed this formula, pH equals to minus log under root Ka times concentration of acid, right? So we need to find the value of pH. The value of Ka is already given, which is 3.236 into 10 to the power minus 7. And the concentration of acid is also given in the question, which is 0.025. So into 0.025 under root answer, negative log answer. So it's going to be 4.0. 4.046. Sorry, guys. pH is basically 4.046. So it's going to be 4.05. Okay. H hydrogen chromate shows an amphoteric behavior. So when this hydrogen chromate reacts with hydrogen ion, it will turn to H2CrO4. So if it is a base, because it is accepting proton, which means it is a conjugate acid. So conjugate acid is basically H2CrO4. If it is acting as an acid, obviously it donates its proton, and as a result, it's basically CrO4 2 negative plus water. So if it is an acid, it must be a conjugate base. Okay, so CrO4 2 negative is a conjugate base of this. Let's move on to the next part of the question. Oh my goodness, define the term first electron affinity. I'll read the data afterwards, but let me solve this definition. First electron affinity is always exothermic, so energy released. When 1 mole of an electron is absorbed in 1 mole of neutral gaseous atom. Okay. Explain why the value of the second electron affinity of sulfur is positive. Second electron affinity is endothermic. See, guys, this is the first electron affinity. Okay. In second electron affinity, this negatively charged sulfur ion will gain electron and it will turn into sulfide ion. So this reaction is exothermic, but this reaction is endothermic. Examiner is asking why this reaction is endothermic. So you know that these two particles are negatively charged. They will experience electronic repulsion. To overcome this repulsion, absorption of energy takes place, which is why second electron affinity is endothermic or positive. Okay. Both S negative and electron experiences repulsion. So to overcome this repulsion, absorption of energy takes place. Hence, reaction is endothermic. Construct an equation for the lattice energy of this constituent gaseous silver ion and constituent gaseous sulfide ion combined together to give 1 mole of silver sulfide. Under standard condition, it is solid. How many silver? We have 2 silver here, so we need to put 2 here. So that's the balanced chemical equation. Examiner is looking for the state symbols, so we need to mention those state symbols also. Okay. So gaseous cation and anion combine together to give 1 mole of ionic solid. That's called lattice energy. That is the concept behind lattice energy. Okay. Next page. Oh. Calculate enthalpy change of atomization in kilojoule per mole of silver using relevant data from table 2.1. It may be helpful to draw a Born-Haber cycle, show your working. So I've told you in the class, first of all, let me write the lattice energy equation for silver sulfide. That's your lattice energy. And it is 1 mole of silver sulfide. Now, solid silver and solid sulfur when 1 mole of compound is formed from its constituent elements in their standard states under standard condition, then it is called standard enthalpy change of formation. So this is going to be standard enthalpy change of formation. Let me check the data. Okay. And this becomes delta H1, if you remember my lecture. This delta H1 involves the atomization of silver and the first ionization energy of silver because it has only plus one charge. So I'm not going to use second ionization energy. Now this has atomization, and then this has first electron affinity plus second electron affinity as sulfur carries 2 minus charge. So delta H1 has 4 different energy values: atomization of silver, first ionization energy of silver, all right, and both of them needs to multiply by 2 because we have 2 moles here. Third, atomization of sulfur. Second, fourth stage is first electron affinity and second electron affinity of sulfur. So I hope it makes sense to you. Make a clockwise arrow in this thermochemical Haseloff cycle. So it's basically delta H1 plus lattice energy minus delta HF equals to 0. So delta HF equals to delta H1 minus lattice energy. Delta HF of silver sulfide is given minus 33. Atomization of silver is given and this value needs to multiply by 2 plus ionization, first ionization energy of silver multiply by 2 plus atomization of sulfur plus first electron affinity of sulfur plus second electron affinity of sulfur. That's your delta H1 ka data minus lattice energy. Okay, let me plug in the values now. Minus 33 equals to, examiner is looking for the atomization value. So it must be 2x plus first ionization energy of silver plus 731 into 2 plus atomization of sulfur plus 279 plus first electron affinity of sulfur minus 200 plus second electron affinity of sulfur plus 532 minus lattice energy of silver sulfide minus 2677. Okay. So the value of atomization of silver is going to be plus 285.5 kilojoules per mole. Okay, I hope it makes sense to you. Suggest how the magnitude of the lattice energy of silver sulfide differs from the lattice energy of copper sulfide. See guys, in both the compounds, sulfide has a common ion, which means anion is basically the common ion. इसका मतलब explanation can be explained on the basis of cation. Now silver has plus 1 charge and copper has 2 plus charge. So the higher the magnitude of positive charge, the higher the charge density, the higher the charge density, the higher the lattice enthalpy. So copper 1 sulfide has a higher value of lattice enthalpy. My bad, hold on. My mistake, my bad. In this compound, silver has a plus 1 charge also. So both of them has plus 1 charge. So charges are same. इसका मतलब if charges are same, so we need to explain it on the basis of ionic radius. Okay, let me give you an example here. Ionic radius of silver and copper. See, down the group, radius increases, which means sulfur has a bigger radius and copper has a smaller radius, right? I hope it makes sense to you. Because there is no data booklet given in the question. So how can we determine which one is high radius and which one is low radius? So we need to consider periodic table in order to explain the ionic radiuses for copper and silver. So silver has a larger ionic radius, copper has a smaller ionic radius. Oh, that was tricky because both of them has +1 charge. Overlook kiya maine usko, okay? So you have to be very, very careful. So silver ion has a larger ionic radius than copper 1 ions. So silver ion has a less charge density so silver sulfide exhibit weak electrostatic attraction hence weak electrostatic attraction than Cu2s, hence its lattice energy is less exothermic. इसका मतलब copper 1 sulfide has higher value of lattice energy. Okay, that's the end of this question. Oh my goodness, that's 18 marks per question. Question number 3, based on entropy. Define the term entropy. It's easy. Disorderness of the system in which dispersal of energy takes place from system to surrounding and vice versa. Place one tick in each row of table 3.1 to show the sign of the entropy change for each process. Steam condensing into water. So the equation for this reaction is basically steam is converting into water. Now, steam has a gaseous state, and gaseous is extremely and highly irregular arrangement of atoms. So this means this has a higher entropy value, and liquid has a lower entropy value because liquid water exhibit extensive hydrogen bonding. Because of that extensive hydrogen bonding, it will have significant amount of order in the system. So technically, during the reaction, reactants have higher entropy products have lower entropy, so entropy of the specific reaction decreases, which means it is going to be negative. Dissolving KCl solid in water. So this is KCl, which is solid. Solid has lower entropy value. When you add water into it, it will turn to aqueous silver ion and aqueous chloride ion. And you know, both aqueous ions has free mobile ions. Because of mobility of ions, they will have more disorderness, have more entropy. So whenever we have more entropy, the value of entropy is going to be positive. So this one has a more positive as oh, positive value. My bad. Examiner is looking for the tick. Oh my goodness. This one and this one. Okay. Concept was same. Anyway, chlorine trifluoride decomposes on heating into its element as shown. Standard entropy values is given. Calculate the standard entropy change. So standard entropy change is equals to standard entropy of product minus standard entropy of reactant Now, in the equation, we have chlorine, and chlorine has a entropy value of 223.1 plus we have fluorine molecule. Its entropy value is 203.0. We need to multiply this value by 3 because we have 3 moles in the equation. Minus reactant, we have reactant ClF3. ClF3 is plus 281.6. Needs to multiply by 2 because we have 2 moles in the equation. So value of standard entropy from this data would be plus 268.9 joules mole inverse and then Kelvin inverse. So it's basically plus 268.9. Okay. Oh my goodness. All right. Group 2 carbonates decompose on heating. The decomposition for one of the group 2 carbonate is shown in reaction 2. Predict the sign of the entropy change for this reaction. See, on the reactant side, we have solid particles. So because of highly regular arrangement of system, reactants have lower entropy value. On the other hand, products has a gaseous molecules, and gaseous molecules have more entropy value, which means during the reaction, entropy of the system increases. So obviously, the sign is going to be positive. And we need to explain the answer. So reactants are solids and have lower entropy value. While product is a gas it has higher entropy value. So entropy increases during the reaction. And whenever entropy increases, value is going to be positive. Okay. Next page. Oh my goodness. That's a different thing. Oh my goodness. Oh my goodness. Figure 3.1 shows the values of the Gibbs free energy change in kilojoules per mole at different temperature for reaction 2. Assume delta H and delta S naught values for this reaction remains constant over this temperature range. Okay. Use the gradient and the intercept on the y-axis in figure 3.1 and the Gibbs free energy change. Calculate delta S naught for reaction 2. The minimum temperature in Kelvin at which reaction is feasible and delta H naught in kilojoules per mole. Okay. That's crazy. That's crazy. So in order to determine the gradient, okay, this delta G is basically Y. Delta H basically is C, that is y-intercept. Temperature is X, and delta S naught is basically M, that is basically your gradient. Okay. So M is technically minus delta S naught. Okay. Remember that. Oh my goodness. So we have 2 points here. The first one is here, and the second one is here. Okay. So at 600 Kelvin, the value of delta G naught is 80. Yeah. Delta G naught is 80. At 600 Kelvin, it is 80. Whereas at this temperature, which is almost 1120 Kelvin, the delta G is basically 0. So at 600, it is 80. At 1120 Kelvin, it is 0 Kelvin. Okay. So delta G is 0 at this temperature. So let me find out the gradient first. Gradient is basically M. So 0 minus 80 divided by 120 minus 600. So it's basically minus 80 divided by, let me calculate this value. 1120 minus 600 is going to be 520. So value is going to be 80 divided by answer is going to be minus 0.1538. So मैं minus 0.1538 को minus 0.154 कर लेता हूँ. Okay. So that's the gradient, guys. I have to calculate the delta S naught, and delta S naught is basically minus, ये माइनस हो गया, और डेल्टा एस नॉट की वैल्यू हमने कितनी निकाली है, माइनस दिस मच, 154. So value is going to be plus 0.154 kilojoules. Not joules, because entropy has to be in joules. Joules, mole inverse, Kelvin inverse. I have to convert this into, okay. Oh, my bad. It's kilojoule actually. I was writing. It's kilojoule. And we need to convert it into joules. So it must be plus 0.154 into 1000. So it's going to be how much? Plus 154 joules, mole inverse, and then Kelvin inverse. Okay. Number third, delta G naught equals to delta H naught minus T delta S naught. By the way, we need to find the value of delta H naught, and the temperature is going to be 1120 because at this 1120 Kelvin, the delta G naught was 0. And when delta G naught was 0, obviously the temperature, the reaction is going to be feasible. And delta S naught is basically 154. 0 delta H naught minus, तो दोनों को मल्टीप्लाई करेंगे तो आएगा 172480 joules, right? So it's basically plus 172480 joules. Convert them into kilojoule. So divide by 1000. So it's going to be plus 172.48 kilojoules per mole. So delta S naught for reaction 2 is basically plus 154. Temperature was 1120 because at this temperature delta G is 0, okay? Because the reaction is feasible. Reaction is feasible when delta G naught is 0 because at 0 we have 1120, okay? इस तरह से सोच लो बात को. And delta H naught is basically plus 172.48. So I can write 172.5. That's the end of this question. Question number 4. Nitrogen monoxide reacts with hydrogen as shown in the reaction 3. So 2 moles of NO reacting with 2 moles of hydrogen converting into product. So the molecularity of this reaction is 4. And molecularity means total number of molecules involved in the reaction. Okay. Rate equation is given surprisingly. So with respect to hydrogen, it is first order. And with respect to NO, it is second order. So overall order is going to be third. Okay. So with respect to NO, it is second order. With respect to hydrogen, it is first order. And overall order is basically third. All right. Predict how the initial rate for reaction 3 changes when concentration of NO is half. See, for second order reaction, if concentration is double, initial rate is quadruple. So if concentration is half, obviously initial rate is going to be 1/4. Okay, next is predict how the initial rate of reaction 3 changes when the concentration of NO and hydrogen are both increased 3 times. If it increases 3 times, obviously the rate of reaction increases by 27 times. Because overall order is third, okay? Suggest why reaction 3 is unlikely to proceed by a mechanism involving only a single step. Unlikely. Suggest why reaction 3 is unlikely to proceed by a mechanism involving only a single step. As we have 4 molecules in the equation, so molecularity is 4. So total 4 molecules are involved in the reaction. And it is very highly unlikely to involve 4 molecules in a reaction, according to collision biomolecular theory. That's tricky part. Four molecules are highly unlikely with respect to collision. Since number of molecules are so high that the collision frequency or collision in a right orientation won't be takes place properly. So, which is why mechanism takes place in single step. Suggest equation for 3 steps of the reaction mechanism for reaction 3. Each step involves reaction between 2 molecules. Examiner is saying 2 molecules. So when 2 NO are involved in the reaction, it's going to be N2 and O2. All right. Now N2 and O2 is reacting with hydrogen, converting into N2O plus H2O. Okay. So यहाँ से H2 यहाँ से O दोनों मिलकर बनाएंगे H2O. What's left? N2O. वो एग्जामिनर ने खुद बनाया हुआ है ना, एग्जामिनर ने ये N2O दोबारा लिया है. And since we have 2 moles of hydrogen in the equation, so I'm going to write another molecule of H2 here, and it's going to be converted into H2O plus N2. See, this will cancel out with each other. This will cancel out with each other. So the remaining equation is going to be like this. And this is the equation is given in reaction 3. So my overall equation is consistent with this mechanism. इसका मतलब ये मैंने mechanism बिल्कुल ठीक किया. Okay. अगर ये overall equation नहीं आती मेरे पास cancellation के बाद, तो obviously मेरा mechanism गलत था. So cancellation के बाद मुझे exactly वही equation मिली है जो examiner ने मुझे यहाँ दी थी. सही है? Suggests a role of NO2 in this intermediate. This is the product and this is the reactant, which means N2O is acting as an intermediate. Let's move on to the next page. My goodness. We have done this equation in A1 in in group 17 elements. When large excess of iodine is used, which means we cannot determine the order of reaction with respect to iodine. So iodine के लिहाज से order is 0 order. Okay. Now in the next part, with respect to thiosulfatine, it is first order, and the half-life for reaction 4 is 720. I mean, is given. So we need to find the value of rate constant, including the units. Okay. So by the way, first order reaction has a half-life of 0.693 over K. 0.693 is a constant value which comes from ln2, right? And T half is given, which is 720 seconds. So K value is going to be how much? 9.625 into 10 to the power minus 4. And the unit is going to be second inverse. because ये हो जाएगा 1/2. Okay, तो second inverse हो जाएगा. Okay, the reaction between iodide ions and peroxodisulfate ions is catalyzed by cobalt 3 ions. The mechanism is similar to the mechanism of this reaction when iron 3 ions is used as a catalyst. By the way, I have done both iron 2 ions का mechanism and iron 3 ions का mechanism. And see examiner यहाँ पर iron 3 ions use कर रहे हैं. ठीक है? State the type of catalysis that occurs in this reaction. Homogeneous catalyst. Because reactants and catalyst exist in same physical state. Write two equations to show how cobalt 3 ions catalyzes this reaction. So first of all, cobalt 3 ions is basically an oxidizing agent. It oxidizes iodide ions into iodine and reduces itself into cobalt 2 ions. Now in the second step, cobalt 2 ions is basically the reducing agent. So it reduces peroxidized sulfate into sulfate ions and oxidizes itself into cobalt 3 ions. So see, reaction start हुआ cobalt 3 ions से मुझे वापस cobalt 3 ions मिला acting as a catalyst, and reactants and catalysts exist in same physical state, which is why. Suggest why this reaction is slow in the absence of cobalt 3 ions. Look, this is peroxodisulfate ion and this is iodide ions. They are reacting together, converting into iodine and sulfate ion. By the way, both the reacting particles are negatively charged. So they will experience electronic repulsion. Because of that repulsion, they will have a higher activation energy value, which is why reaction is slow. Both H2O82 negative and iodide ions experiences repulsion due to similar charges. Hence, they will have a higher activation energy. So this makes the reaction slow. Oh, that's the end of question number 4. Let's move on to the next question. Describe and explain the shape of benzene. Your answer includes shape, bond angles in the ring. Hexagonal, ring shape with planar geometry. With an angle of 120 degree. Okay, next. Hybridization of the carbon atom. All 6 carbon atoms are sp2 hybridized. Next, how orbitals overlap form sigma and pi bond between the carbon atom in the ring. sp2 hybridized orbitals of carbon undergoes head-to-head overlapping, also called head-on overlapping, to form a sigma bond. Next, sidewise overlapping, also called lateral overlapping, um, of p orbital give pi bond. Okay. Okay, next B part. This figure shows two reaction of benzoic acid. So in the in reaction 5, from here to here, the pi bond of benzene disappear, which means this is going to be hydrogenation reaction, also called reduction, also called addition of hydrogen, in which I'm going to use hydrogen gas in the presence of nickel catalyst. And reaction 6, I need to attach an acyl group, which means acylation takes place. So reaction 6 is acylation, and for that we need acyl halide as a reagent, and reaction 5 is basically hydrogenation. So suggest reagents and conditions for reaction 5. To reagents, hydrogen gas in the presence of nickel catalyst. And reaction 6. So from this segment, I can get the reagent, which is CH3 taken to CH, then COCl. That is going to be the reagent. अब halogen आप कोई सा भी यूज कर सकते हैं, वो कोई प्रॉब्लम नहीं है. So it's basically CH3 taken to CH, CO, Cl, and AlCl3 is acting as a catalyst. State the type of reaction in reaction 5, hydrogenation or reduction. Addition of hydrogen is reduction, also called hydrogenation. Okay, let's move on to the next page. In the electrophilic substitution reaction of arenes, different substituents can direct to different ring position. Describe the directing effect of this group. It is an electron donating group, orthopara directing group, activating group. So it directs the electrophile towards ortho position and para position, that is 2, 4, and 6 position. Okay. So electrophile surely goes or surely attached to second, fourth, and sixth carbon atom. CH3, CH2 is an electron donating and ortho para directing group. So it directs the electrophile towards second, fourth, and sixth carbon. Okay. The alkylation of arenes uses a mixture of this compound and this to generate electrophile. Write an equation for the formation of this. Easy piece of ऐसे क्वेश्चन आने चाहिए जिसमें ज्यादा सोचना ना पड़े, है ना? FeBr3 is basically a catalyst. It will turn to FeBrO4 negative plus CH3. CH2 is basically your electrophile. Include all relevant curly arrows, charges, draw the structure of the organic intermediate. So first of all, let me show you that the pi bond interacts with this electrophile, and as a result, a pi complex is formed. This CWH will remain as it is. And obviously this CWH is a meta directing an electron withdrawing group. So it directs the electrophile towards meta position, that is third and fifth. So this electrophile either attached with the third carbon atom or with the fifth carbon atom. See, examiner has attached this electrophile with the third carbon atom. All right, which means this is going to be CH2, CH3. And obviously I need to show hydrogen atom on this. इस कार्बन को छोड़ के बाकी तमाम कार्बन एटम्स को डॉटेड लाइन और प्लस चार्ज से रिप्रेजेंट करोगे. दैट्स द इंस्ट्रक्शन आई हैव गिवन यू ड्यूरिंग द थ्योरी क्लासेस and represented by plus sign. Now hydrogen removes in the form of hydrogen ion and bond shifts into the ring so that we can eliminate the positive charge of carbon, and that's how you will get the stable product. Okay, examiner ने इसको skeletal structure की form में लिखा है. It doesn't make any difference. Write an equation to show how FeBr3 is regenerated after reaction. Oh, that's cool. FeBr4 negative is reacting with hydrogen ion, converting into HBr plus FeBr3. Thank God, reaction is finished. Let's move on to the question number 6. Compound Z is used in organic synthesis. Complete table 6.1 to show the number of sp, sp2 and sp3 hybridized carbon atoms present in one molecule of Z. By the way, if we have a triple bond, then we can have sp hybridization. So this carbon atom has triple bond, so it has sp hybridization. sp2 is basically double bonded carbon atom. So this is going to be double bonded carbon atom. So we have one sp2 hybridization. This is sp3, sp3, sp3. So there are three sp3 hybridized carbon because they are single bonded carbon atom. Okay. Z undergoes different reactions as shown in figure 6.1. When excess HCl is used under heat, obviously this nitrile will turn to CWH. This NH2 is basically proton acceptor, so it will turn to NH3 plus, and this amide will hydrolyze in the presence of an acidic medium, will turn to carboxylic acid. My goodness, that's cheekiest one. Hold on. मैं जहां चेंजेस होंगी वहां पर रेड पेन से लिख. Okay, so that's the salt after the hydrolysis of an amide is formed. After accepting the proton, it will turn to NH3 plus, Cl minus, and this Cn will turn to CWH. ओके, और मेरे ख्याल से ये सब कुछ किया हुआ है हम लोगों ने, आई बिलीव आपको आना चाहिए। सॉल्ट टेस्ट क्यों बनाया मैंने? दैट वाज अ मिस्टेक गाइस। Since the medium is acidic, there will be no salt. It has to be COH. Grave error I have done. Now, ethanol chloride can react with alcohol, can react with phenol, can react with amine. There is no phenol, there is no alcohol, only amine is given, which means both of them are reacting together, converting into an amine. So it's going to be like this: NH2. This amide is neutral, it will remain same. This is NH. It is attached to CO and CH3. This is CH2 and this is CN. Okay. Now, lithium aluminum hydride in excess is used, which means reduction takes place. So CN will turn to CH2NH2, and this amide will turn to CH2NH2. So changes C CH2NH2, CH2, CH, NH2 will remain as it is. This is CN, and this CN will turn to CH2NH2. Okay. Okay, so that's this conversion. This CONH2 is amide. When treated with lithium aluminum hydride, will turn to CH2NH2. Okay. This CN is nitrile. When treated with lithium aluminum hydride in excess, it will turn to CH2NH2. I hope it makes sense to you. Okay. And since this is amine, cannot react with lithium aluminum hydride. Name the two types of reaction occurring. So this is called in reaction 7. Okay. In reaction 7, this is called acid hydrolysis. And when it accepts proton, it becomes an acid-base reaction. Acid hydrolysis, because cyanide is converting into carboxylic acid. An acid-base reaction, because amine, that is NH2, will accept a proton. Draw the structure of the organic product of reaction 7, 8, and 9. I've done that. So, okay, let's move on to the next page. Compound Z is dissolved in D2O and analyzed by carbon-13 NMR and proton NMR spectroscopy. Predict the number of peaks in carbon-13 NMR spectrum of Z. Here is Z. Okay, this one is Z. पीछे कहीं Z बना है, ये रहा. Okay, let me take out the structure of Z. So this is the structure of Z, guys. And we are looking for the carbon-13 NMR. So we have first carbon, second, third, fourth, and this one is fifth. So we have 5 peaks of carbon-13 NMR. Okay. The proton NMR of spectrum Z D2O gives 3 peaks for the proton environment, A, B, and C as shown. Complete table 6.2 for proton NMR of spectrum Z. Okay. In D2O, this peak will disappear. Okay. All right. Now let's apply n+1 rule on this. We have 1 hydrogen atom in the neighbor carbon. So it's going to be 2. It's going to be duplet. So C is basically Name of a splitting pattern, duplet. And this basically alkyl next to nitrile. So alkyl next to nitrile is given, which has a shift of 2 to 3, 2.0 to 3.0 delta. Okay. B. Let's apply n+1 rule. We have 4 hydrogen atoms on the neighbor carbon. So 4 plus 1 becomes 5. 5 means quantate. And this is alkyl group next to amine. Alkyl NH2. Alkyl NH2. Alkyl NH2. Yani alkyl next to more electronegative nitrogen. So its value is 3.2 to 4.0. Let's talk about A. Let's apply n+1 rule here. So we have 1 hydrogen atom in the neighbor carbon. So it's going to be 2. It's going to be duplet. And this alkyl next to carbonyl, duplet. Alkyl next to carbonyl 2.2 to 3.0. Okay. That's an easy thing. That's not tough at all. Okay. That's the end of this question, guys. I'm happy. Let's move on to question number 7. Phenyl methanol and 4-methyl phenol are isomers. Both of them are isomers because they have same molecular formula but different structural formula. Complete table 7.1 to show the relative acidities of benzoic acid, phenyl methanol, 4-methyl phenol, and water. So 4-methyl, so phenyl methanol has the lowest because alcohol is neutral. उससे ज्यादा water, उससे ज्यादा 4-methyl phenol, and benzoic acid is the most acidic one. Oh my goodness, explanation. Now in benzoic acid, this carbon is attached to more electronegative oxygen atom. So because of negative inductive effect, ionization of hydrogen becomes easier, and also it stabilizes the anion. In benzoic acid, carbonyl carbon is attached to more electronegative oxygen. So due to negative inductive effect, ionization of hydrogen is easier, and also stabilizes the anion. That's a lot of writing actually. For 1 mark, that's a lot of explanation. In this 4-methyl-phenol, the lone pair of oxygen is delocalized with the pi bond of the benzene ring. Okay. So ionization of hydrogen uh, is not easier. In 4-methyl-phenol, lone pair of oxygen in OH group is delocalized with a pi bond of benzene okay in phenyl methanol. This is the positive inductive effect of electron donating alkyl group. So it increases the electronic density on the oxygen atom. As a result, oxygen cannot pull the electron from hydrogen, so ionization is not easier. But that's a lot of explanation, guys. 4 marks is come hai yaar, 4 marks. In phenyl methanol, alkyl group has a positive inductive effect. So it increases the electronic density on oxygen. So OH bond becomes stronger. And ionization becomes difficult. Also destabilizes anion. Oh my goodness. So water जो है वो तो ऑटोमेटिकली क्लियर हो गया मेरे ख्याल से. माय गुडनेस. 1 मार्क तो इसके उसका था ऑर्डर का, और 3 मार्क्स की एक्सप्लेनेशन. तो मैंने 3 मार्क्स की एक्सप्लेनेशन बेंजोइक एसिड के लिए दी, फिनाइल मेथोल के लिए, और मिथाइल फिनाइल मेथनॉल के लिए दी. आई थिंक इट्स मोर देन इनफ. 4-methyl phenol reacts readily with sodium. Complete the equation for this reaction. Okay, sodium can react with phenol, and as a result, I'll get what? ONA plus hydrogen gas. So to make H2, I need two hydrogen atoms from this side, which is why I will put two here. So I'm going to put two here. I'm going to put two here also. Okay, that's the balanced chemical equation. If you remember, आप 1 मोल के लिए भी बना सकते हैं. मैंने आपको 2 मोल के लिए सिखाई है क्लास में, तो इसलिए मैंने एज इट इज जो क्लास में सिखाया वही मैंने आपको यहाँ बता दिया. You can write the equation for 1 mole, but in that case you need to put half here for 1 mole. Okay. Let's move on to the next page. Oh my goodness. Under certain conditions, ethane 1,2-diol reacts with propane 1,3-dioic acid. Allah Akbar. Okay. And because of that, compound X is formed and polymer Y is formed, which means these two reactions are different from each other. Okay. So let me write down the polymer first. My goodness. So I'm going to write like this. OH comes from carboxylic acid and H comes from alcohol will turn to water. All right. Obviously, OH comes from carboxylic acid and H comes from water. So the structure of polymer is going to be like this. CO, CH2, CO, then oxygen, then CH2, then CH2, then oxygen, and then this bond continuation. Okay. Oh, that's the structure of this polymer. I hope it makes sense to you. And we have n moles of water from here. Draw the structure of the organic product X shown in figure 7.1. So वो तो मैंने भी determine करना है. Okay. So इस दोनों को okay. Let me show you one thing. This is COOH. COOH. Now we have OH, CH2, CH2, and this is OH. Okay. What we can do is that OH and H combine together to give water. Then OH and H combine together to give water. So I'll get 2 moles of water from here. Plus, this is going to be CO. CH2. Oh my goodness. CO. It is attached with oxygen. Then CH2. Then CH2. Then oxygen. Then CH2. Then CO. And this CO will attach to this oxygen. Okay. So to make the skeletal structure, I think the best thing is इसको हम इस तरह से लिख लें. CO, CH2, CO, oxygen, CH2, CH2, and oxygen. Yeah, that's the possibility. I can write that. But दोनों ठीक हैं ये. Both are acceptable. मैंने इसमें skeletal नहीं शो किया इन दोनों को. इसमें शो कर दिया है. So examiner ने skeletal में दिया है तो product भी skeletal में जाएगा. So I'm going to write this one. Okay. I'll go with this one. That is the answer. Name the type of reaction for reaction 10. So reaction 10 is basically condensation because two molecules are combined together. Addition elimination भी कह सकता हूं मैं. And obviously this formation of polymer is condensation. Draw a section of a polymer while showing only one repeating unit. The new functional group form should be displayed. So one repeating unit. So one repeating unit is basically, this is the one repeating unit, guys. So let me draw this structure and let me write it down here. So that is the one repeating unit, okay? The new functional group form should be displayed. So this is the new functional group form. That functional group is ester, okay? So formation of ester, esterification भी कह सकते हैं हम इसको. That's the end of this question, guys. Question number 8. My goodness. Describe the difference in reactivity between ethanol chloride and chlorobenzene with water. First of all, chlorobenzene is aromatic alkyl halide, so it is less reactive than ethanol chloride. So chlorobenzene is less reactive than ethanol chloride. Why? Because lone pair of chlorine is delocalized with the pi bond of benzene. As a result, double bond is formed between carbon and chlorine. And this makes the bond stronger. That's a lot of explanation. If you want each and every word, that's a lot of explanation actually for 2 marks. Carbonyl carbon is highly electron deficient. Due to positive inductive effect of more electronegative oxygen and chlorine carbonyl carbon is highly electron deficient. So more reactive towards water. Oh, thank God. The structure of compound V is shown. Name all the functional groups in V. This one is nitrile. So this one is nitrile. This one is amide. This one is ketone. And this one is obviously an ester. Okay. Reduce the number of possible optical isomers. Oh my goodness. For that, I need to determine the chiral carbon atom. So this must be the chiral carbon atom. This must be another chiral carbon atom. And this must be another chiral carbon atom. So we have 3 chiral carbon atoms. So I'm going to use 2 to the power n. So I'm going to write 2 to the power 3. So it's going to be 8 isomers. That's what we have done in A1, right? Suggest one reason other than better biological activity and lower dosage required, why it is beneficial to synthesize a single optical isomers of V. When we use single optical isomers, obviously we don't need to separate it from the mixture. We do not need to separate. Okay. Let's move on to the next page. Oh my goodness. Sample of V. So this is your V. First, let me copy this structure. Okay. Let me write it down here. This is the structure of V. An examiner is looking for the hydrolysis with excess hot aqueous alkali. The products are isolated from the reaction mixture at pH 12. Okay. So for hydrolysis, amides break होगा और ester भी break होगा. So first of all, with water, I'll get 2 different products. This is CN. This is CO. And this is going to be OH. Plus, this is going to be NH2, CH2, then CO, then this, then this, then this, then this oxygen, and then this. And this is double bond. Okay. So this is the hydrolysis case, but in the presence of hot aqueous alkali, which means oh my bad. Hold on. When ester was hydrolyzed, it will turn to carboxylic acid and OH. Okay. That was a grave mistake. बहुत carefully काम करना होता है, ठीक है? It will turn to CWH. Like ये मैंने CWH कुछ बहुत ही unprofessional way से बना दिया है. It has to be like this. Yeah, it makes sense now. Okay. So when we use alkaline medium with pH 12, obviously this carboxylic acid reacts, my goodness. Am I doing any mistake? Oh, my bad, my bad. Look, this is nitrile. Nitrile under alkyne hydrolysis will turn to CWH. So it will turn to CWH also. Oh my goodness, that's the logical thing. Now we have alkali. So when we have alkali, they will combine together. Then they will react with NOH to give salt. So the salt is going to be like this. My bad. Salt is going to be like this. CONA and CONA. That is a salt plus NH2 will remain as it is because it is also an alkali. This ketone will remain as it is. This OH will remain as it is, and this CWH will turn to salt. Okay, so these are the two products examiner is looking for. Okay, I hope it makes sense to you. Another issue, examiner didn't say NaOH. Examiner said hot aqueous alkali, which means it has to be CW negative. Okay, I hope it makes sense to you. Okay. Next part. Oh my goodness, the polypeptide forms from 4 amino acids is completely hydrolyzed and then analyzed by gas liquid chromatography. The chromatogram produced is shown in this. Now, look at this chromatogram. This compound A has a smaller retention factor. Or smaller retention time. That means this sample will comes out first quickly from the glass column. So it has a less affinity with stationary phase, that is high boiling liquid like Bexy polymer. If D has a longer retention time, then it means it will spend more time in the glass column. Ultimately, it has a strong affinity with the stationary phase. That is high boiling liquid like Bexy polymer. Okay. So first of all, you need to understand this retention time thing. Okay. Now we have total 5 peaks. My goodness, 1, 2, 3, 4 peaks, which means sample contain 4 compounds. Area under the peak is given, so we need to add them quickly. My battery is, oh my goodness, let me recharge. Yeah. Okay. So it's 28 plus 58 plus 13 plus 42. So the total area is basically 141. Okay. Let me recall it again. 28 plus 58 plus 13 plus 42. Yes, 141 is the total area. All right. The peak, the area under the peak gives the information about the proportion of substance present in the sample mixture. Calculate the percentage by mass of amino acid. Okay, percentage of A is basically area of A, which is 28, divided by total area, which is 141 into 100. So 28 divided by answer into 100 is going to be 19.85. 858%. So percentage is going to be 19.9%. Okay. The retention time for amino acid D is longest. Explain why D has a longer retention time than other amino acid. Because D has a stronger affinity with the stationary phase and stronger affinity means both compound D and the stationary phase have different sort of interactions or intermolecular forces. Which means compound D forms stronger interactions interaction means intermolecular forces with the stationary phase. That's the end of this question. Let's move on to the next one. Oh, that's the end of this paper. Thank God. Thank you very much, guys.